Okay, so we're kind of doing the sections out of order. Um, 7.6 is kind of the hardest version of factoring, so I kind of want you guys to get a little bit more comfortable before we do that one. And the 7.7 is actually easier, so um, fact, I can't spell. Factoring special cases. And so remember in the beginning part of the chapter, we had special cases that we like multiplied. And they're the same like cases, just remember we're going like backwards. So the easiest, I think, of all the kinds of factoring is difference of squares. Because it's going to have two terms to begin with. So it should stick out that, hey, this one's different. All the other kinds have three. So that's kind of a big deal. But so if it's difference of squares, it has to have two terms. It has to be subtraction. And you have to be able to do the square root of both terms. And typically, like if it's a problem like that, you can. It's not like there's very few that they give you and then say, oh, well, can't do it. So a simple version of that problem okay, so the directions will say factor in some form or another. I'm looking at the directions. Yeah, factor the polynomial. So okay, two terms, subtraction. What's the square root of x squared? It's x. So just anything that's squared, the square root is, y squared is y, a squared is a. Can you do the square root of 25? Yeah, 5 times 5. So the last term is negative, so that means one of each. X and x, 5 and 5. Done. Okay, it's fairly straightforward. So 4x squared minus 9. Can you do the square root of 4? Yes. Can you do the square root of 9? Yes. It's two terms, it's subtraction. So because the last term is negative, it's one of each. Square root of 4 is 2. Square root of 9 is 3. Okay, it doesn't matter. Sometimes they put them in a different order. So you might have 16 minus, we can use 9 again. And that's okay, just, it's plus, it's minus, because the last one's negative. Square root of 16 is 4. Square root of 9 is x squared is 3x. Okay. There'll be a few of them that you have to, let me see, 1, 2, 3, 4, no, 1, 2, 3 of them that you have to solve. So, like if it was, I'm just going to kind of, bring this down here. If it said equals 0, well, factor it, and then you just do the x plus 5 equals 0 and x minus 5 equals 0 and solve them. Okay, pretty straightforward. All right. So, difference of squares. The other one is called a perfect square trinomial. And there's really, in my opinion, two versions of this problem. So version 1 is when there's no number in the front of the x squared. And really, I think we should just do the problem when in that situation, like we did the problems yesterday. Don't even worry, is this a perfect square trinomial? Is this like what we did yesterday? If there's no number in the front, treat it the same. So can I take anything out? Is there something in common? There's not. Excuse me. The last, what are the signs going to be? The last one's positive. So that means the signs are the same. Well, are they both positive or are they both negative? Well, since the other sign is a negative, it's one of each. And then x and x go there. So then what times what is 16? That adds up to 8. So if I'm looking at 16 and I say, well, 16 times 1, that doesn't work. 8 times 2, that doesn't add up to 8. 4 times 4, that adds up to 8. And so we end up with the same thing in the parentheses. When that happens, you need to write the answer like that. Okay? You don't just leave it x minus 4, x minus 4. It's like not reducing a fraction at the end of a problem where you get a fraction as an answer. Okay? So if there's no number in the front, I would just do it like yesterday. Don't worry about perfect square or not perfect square. However, when there is a number in the front, that definitely changes things, because putting a number in the front of the x changes a lot of things in the problem and makes it much more difficult. So, I can't do like what times what is 9 that adds up to 12, because there isn't anything. So you might look at it and go, well, what do I do? Well, you can't do that when there's a number in the front. So on the problems today, you still want to look at, is there something in common? And I'm going to get to a problem where there actually is in a minute. But there's this whole like guess and check thing that we're going to do at some point. But before you do that, let's see if it's a perfect square. So you have to ask yourself a few questions. So number 1, last term positive. So the 9's positive, I'm good. Square root of the first and third term. Can I do the square root of 4? 2. Can I do the square root of 9? 3. Okay, so yes, I can do that. That doesn't mean it's the answer, though. In a really, really high percentage of the time, yes, that will kind of work. But there is a percentage of the time where it won't work. So you got to ask yourself the third question. Or you got to do this. Multiply square roots together and times 2. Goodness, sorry. Does it equal the second term? So multiply the square roots together. Well, square root of 4 is 2. Square root of 9 is 3. So 2 times 3 is 6. And times 2. 6 times 2 is 12. Does it equal the middle term? Yes, it does. So, we did the square root of 4 equals 2. Square root of 9 equals 3. We did 2 times 3 is 6. And times 2 equals 12. And that equals the middle part. So that means I do have a perfect square trinomial. Okay, so a lot of like work to some extent. But this is still easier than like what we haven't like talked about yet. So I do need to figure out the signs. They're both negative. The 9's positive, that means the signs are the same. The 12's negative, so both negative. And then because I was able to do all this, it is just the square root of 4 is 2. And the square root of 9 is 3. And I would need to write my answer like that. Okay. So, it is possible, to make a 9 out of 9 times 1. So it's not always going to be a square root. It probably will be in this section because that's what we're learning about. But when we move on to problems later, you need to be aware of that. Okay. It just became this problem that we just did. So your very last couple of problems, I think you're going to do those last 3 problems. You're going to have to start, and really we should start every problem with asking yourself what is in common. And most of the time, or not, a high percentage of the time, there will not be anything in common. Okay, so just be aware of that. But we do need to ask ourselves that question each time. Okay, so I could have a problem like this. So I need to ask myself, is there something in common? Yes, I can divide both of those by 2. So I take a 2 and I divide it back, which we did at the end of the first part of the chapter. So 2 divided by 2 is 1. So there's a 1 in front of the x squared. 32 divided by 2 is 16. Now I factor what's left over. Okay, 2 terms, subtraction, square root, that's difference of squares. X plus 4, x minus 4. Okay, so, excuse me. If I had, let's see. When the numbers are bigger like that, there should be a little bit of a clue that I could take something out. We don't do a lot of problems with like bigger numbers like that. So what's in common? I always start with the smaller number and say like, okay, like, well, 12. Can you do 36 divided by 12? Yeah. Can you do 27 divided by 12? No. So go back to the 12. 6 can go into 12. Like I want to do the biggest numbers I can. Can 6 go into 36? Yes. Can 6 go into 27? No. Go back to 12. 4. 4 into 12? Yes. 4 into 36? Yes. 4 into 27? No. So here's another thing that like I want to, and I've did this on purpose. I just did 3 numbers and they all didn't work. And they all didn't work with the 27. And if you notice, I tried 12, 6, 4. They're even numbers. Okay, so if you have 2 even numbers like I did on the top one, then an even number is going to probably be the one that works. But because 27 is odd, it's going to be an odd number. So 3. 3 into 12, yeah, 4 times. 3 into 36, yeah, 12 times. 3 into 27, yeah, 9 times. So I can take a 3 out, and when I divide it back, if you notice, okay, so it would be, in this time, instead of minus, it'd be plus because the 12 is positive in the middle. So 9 at the end means signs are the same. Well, which sign? Okay, well, this one's positive, so I do both positive. And then you would need to write your answer like that. Okay, so the last section of problems you're going to do, there's going to be something in common in all of those. So the last 6 problems. Okay, so you'll do some at the beginning that are just difference of squares. Then you'll do some that are just perfect square. Then you're going to do some where you have to solve. And so there'll be a difference of squares and a perfect square, like kind of mixed together. And then you'll do some where you're going to have to take something out. Okay, so it's a decent number of problems today. But a lot of these, like, you just get better by trying them. So there's not really work to show, in most cases. So you won't have to necessarily do a bunch of writing, but just trial and error, keep trying them and they work. Okay. All right, so difference of squares, perfect squares. These are the second and third types of factoring. Okay. All right. Have a great day, guys. We'll see you tomorrow.